Physics Media, Snell's Law. Refraction is the bending of light as it travels from one material into another. In our experiment, we will be observing refraction from air into gelatin. There are some common examples of refraction, including rainbows and objects as they appear in water. Snell's law is used to describe refraction. It shows when a ray is transmitted into a material with a higher index of refraction, it bends to a smaller angle, and when a ray is transmitted into a material with a lower index of refraction, it has a larger angle. We will be using gelatin, a protractor, laser pointer, and petri dishes to measure the angle of refraction of an increasing density of gelatin using a constant of 1 cup water per trial and increasing gelatin using 2, 4, and 6 packets. We will then use the following equations after gathering our data. We expect that with the increasing density of the medium, the higher the index of refraction and thus a smaller angle and speed of light. After making our mixtures, we note that with the increase of gelatin, there is a gradual change in color indicating the increase in density. Using graphing paper, we pointed the laser to the point of intersection and used that to measure the angle of incidence. We then determined the angle of refraction for each yellow container by placing a point where the light leaves the container and measuring the angle. After determining the angle of incidence and the angles of refraction for each container, we then put them into a chart. We then use the data shown in this chart to determine the index of refraction and the speed of light. As the chart shows, with increased density of each mixture, there was an increase in the index of refraction and decrease in the speed of light. Our results effectively demonstrated the application of Snell's law to the relations between angle of refraction and index of refraction. In conclusion, in a material with a higher density, we observe a higher index of refraction, a smaller angle of refraction, and a slower speed of light. This experiment was conducted following CDC guidelines to avoid the spread of COVID-19.